Hello, kids. We're going to talk about the review lab now. We're going to do the part 3, properties of metals and nonmetals on the periodic table. Got mine, you got to have yours. Okay, we'll go really quick. Periodic table is separated into different sides by this dark staircase. Oh, I can't, I got to do it this way. Dark staircase right here. Everything in this top corner, the top corner are nonmetals plus hydrogen. All the other elements are metals. There's only 22 nonmetals, hydrogen and 21 in the top right-hand corner. And that black staircase separates the metals from the nonmetals. But it's really kind of important too because it starts with the atoms that touch. We're going to go to them. Ready? Boron, aluminum, silicon, germanium, arsenic, antimony, Sb, antimony, tellurium, polonium, and astatine. Now, there are 9 atoms, 9, that touch the stairs, but not all of them are the same. We're going to talk about them. Some of them are on the metal side, some of them are on the non-metal side. Now, if you touch the line, you're a special kind of atom. It's like if you were born in America, you're American. If you were born in Italy, you're Italian. Some people are Italian-American. It's kind of like, yeah, my family's from Italy, so I call myself Italian-American. You kind of like 2 things at the same time. You can't be a metal and a non-metal at the same time, but out of those 9 elements, 7 of them are called metalloids. Sometimes they're called semi-metals. They are elements that are metals but have some non-metallic properties, or they're non-metals and they have some metallic properties. Now, out of those 9 that we just did, 2 of them, aluminum and polonium, Al number 13 and polonium 84, Po, aluminum and polonium are just metals. They just happen to touch the line and you got to deal with that. That's like an exception. 7 elements are called metalloids. 7 elements are called metalloids. They are metals. There's only a couple of the metals, right? We got germanium and antimony that are metals, but they have some non-metallic properties. For instance, antimony is a metal. Usually you hit a metal and it flexes, it bends, it's malleable. You hit that one, it cracks. It's brittle. That's a weird thing for a metal. On the other side, you have boron, silicon, arsenic, tellurium, and astatine. For instance, silicon, as a non-metal, you melt it and pour it, it comes up, it shows up like a mirror. It's so shiny or luster. That's usually a metallic property. Also, silicon, they make computer chips out of it. Non-metals don't conduct electricity, but silicon does very well. So there's some exceptions. They're called metalloids. Now, metalloids like Italian-Americans. Metalloids can be metals or metalloids can be non-metals, but they also are metalloids and they have a separate distinction. All the other elements over here are metals and all the other elements up here are non-metals plus a hydrogen. Now, let's see what else we got here. Metals, non-metals. Metals, they give up electrons, they form cations. The non-metals gain those electrons, they form anions. The noble gases in group 18, they don't make any ions at all. They're special and aloof and they don't deal with it. Got this really big chart. Now, in order to do this really big chart, you got to learn a little bit about these elements. Now, on the website, there are 4 sheets. This one says titanium. This one says silver. Do you notice how hard it is for me to do this? It's like a double mirror image here. I get all confused. Silicon and sulfur. I actually have 4 elements right here. And if you were in a class right now, you'd be able to touch these 4 elements. Literally, you could touch them. So let's go through them. Sulfur's first. Sulfur is a non-metal, element number 16. I'm going to take a chunk of it out. Now, things about sulfur. See it? It's like a chunk. But you know, I'm really strong. I can break a little of it off. I get some of that little dust on me. Sulfur is a non-metal. And non-metals tend to be what's called brittle. If you hit it with a hammer, it's going to crack. It's going to break apart. It's going to turn into dust. At the bottom of the jar, you see there's a little dust. Not so much because it's chunks, but it shakes up and it shatters apart. Non-metals are not very shiny. As a rule, they're dull. They don't conduct electricity. They make anions. They are brittle. There's a whole bunch of properties. You're going to look at these sheets, right? They're on the website on the lab section. You're going to look at these sheets. You find the one here for sulfur. It's the, what do we got here? The third one down. Oh, the last one. All kinds of stuff. What else do I got to say about this? Oh, you can figure out the protons, neutrons, electrons. There's a whole lot of things in here. You should read this. Next element up, we're going to do is titanium. Titanium, metal. Titanium is a cool metal. Got two pieces. See how shiny it is? Catches the sun, catches the light, a little bit of sparkle to it. It's a little dull. It's been laying around for a long time. But see, look at that. Shiny, shiny. Where is it? Right there, shiny. Metals tend to have high luster. High luster, they're shiny. They conduct electricity. They make cations. This particular metal is very, very low density, but it's also super duper strong. If I had more money, right, if I wasn't a school teacher, if I had more money, I would have a bicycle made of titanium. My bicycle's made of aluminum. Aluminum's nice, but it's a little more dense than titanium. Titanium you can make thinner. You don't need so much, and it's super duper strong. I got another piece of titanium here. This is an old piece of titanium. See, it even says titanium on it. It's a little shiny. It's a little dull too. See how I scratched it up? See where I scratched out some of that oxide? It's really bright. That's luster. This piece of titanium, ready? Can't bend it. Look how skinny this thing is. Skinny. Holy cow. It's like a piece of aluminum foil almost. So strong. Cannot possibly bend it. Super strong. Metals have different properties. You know, not every metal has got the same property. They're not all the same. Metals are different from each other too. Titanium is a metal, and it's different than some of the other metals. The next element we got is called silicon. Silicon, there's a whole bunch to know about silicon. Now, this is a small little piece of silicon. Oh, it's breaking apart. This is really hard to see because it's zoom. See how it sparkles? Look at that, sparkly. Oh my gosh, you can make an earring out of this stuff. It'd be beautiful. It's very small. Just dropped a little piece on my laptop. Now, this piece of silicon is a non-metal. It's like a little piece of glass, a little chip. Unfortunately, we used to have some big chips, but kids would play with them and pinch them and, you know, they would crack. And so now we got a whole bunch of little chips. But silicon is a non-metal, and non-metals as a rule, are not very shiny and they don't conduct electricity. But you know what? You know what's special about silicon? Let me find the right chart here. Silicon touches the black line. That makes it a metalloid. It's a non-metal and it's a metalloid at the same time, which means it's a non-metal, it's brittle, right? But it conducts electricity and has shiny properties, a luster. That's a metallic property. So some properties are kind of crossover. It does both kinds of properties because it's a metalloid. And the last element I'm going to show you is called Ag. Ag. You know what Ag stands for? Oh my gosh, there's too many of them. Got to get some back. Let me get a couple of them. Oh my gosh, it's all over the place. I don't want to drop it. It's really expensive. Look at that beautiful thing. See it? It's a little tomahawk-shaped piece of silver. I can make this another earring. I have an earring made of silver here too. Silver is a beautiful element, number 47. It's actually a remarkably good conductor of electricity. Nope. Did I drop any? I don't want to lose any. I'll take another peek in a minute, but I don't see any on the floor. Silver conducts electricity really well, better than titanium and better than iron and better than copper, and copper does it pretty well. Different metals have different properties. It's also really, really shiny. That's why we make jewelry out of it. Silver also doesn't react very much. That's why it stays shiny forever. It's not a precious metal to make jewelry out of because it is. it is precious because it doesn't react. And that's why once you make something out of it, it stays pretty forever. Could you imagine you get married with a ring made out of iron? Yeah, with this ring, I'd be wed. And like 6 months later, as long as your spouse takes some showers and gets it wet sometimes, it'll rust and disappear. It'll rust into iron oxide and it'll just disappear. You want a ring like gold or silver that doesn't ever oxidize, turn to rust and disappear on you. Silver, much, much more malleable than the titanium. Titanium is tough. You can bang your bicycle into the garage. It doesn't dent. You can make a golf club out of that. What a waste of titanium, a golf club. But whoosh, you can hit the ground. It doesn't bend. Titanium is tough. Silver is pretty. Way prettier, but not as strong. Different properties for different things. So we have nonmetals, we have metals, and there's some metalloids. The different properties you got to be aware of. Metals tend to be malleable. Ductile means you could pull into a wire. They are lustrous or shiny. They conduct electricity. They make cations. Nonmetals are like the opposite. They're dull and boring. A lot of them are gases. They can't be shiny. Sulfur is kind of a rock. They make anions. They don't conduct electricity. They're different. And metalloids have kind of both properties. So for this chart in the lab, you have to go through, you're going to tell me all that apply. Is sulfur a metal, a non-metal, or a metalloid? Now, you're either a metal or a non-metal, but one of them is a metalloid. What else we got here? Chemical symbols, that's on the periodic table. List all of the ions that the atom makes, right? So some of them you're going to find out make more than one ion. By the time you do this lab, you'll know about that. What's the melting point? You're going to get it in Kelvin, convert that to centigrade. Is it lustrous or dull? Is it shiny or is it boring looking? You decide. Would the element conduct heat? Yes or no? Is the element malleable and ductile, which means you can pound it flat or draw it into a wire, or is it brittle? One or the other. Is it malleable and ductile, or is it brittle? Can it conduct electricity? Yes or no? What is the ground state electron configuration? I got that hidden right on a periodic table for you. And then write a possible excited state. You know how to do that already. And then how many protons, neutrons, and electrons. So after that, it's not too much. You got to make the graphs. You got to answer some questions. Look at all these questions. See what it says right at the top? Put all questions on freaking loose leaf paper. It doesn't say that. It says loose leaf paper. Don't squeeze it in this little piece of paper. Do the work. Spread it out. Spaces in between so I can write you little notes so I can help you learn more. There's 10 questions. Do them. And then there's a rubric. Read the rubric. Now, honestly, I feel really bad because on the other side of the room, I forgot. I got to show you something. So give me 20 seconds. I'm going to run over there and run back. I'm going to make you laugh. Oh, no. Where is it? All right, I'm almost there. Hey, kids. I have had a can of dog food here since my first day on the job. And I don't have it right now because I'm a Zoomer. And this is not the normal way to be a teacher. I hope somebody didn't throw it away. And worse, I hope nobody ate it. It must be around somewhere. I was going to show you a can of dog food that looked like this. It's not really that big. But it's called Alpo dog food. I actually have a can of, I don't know, beef chunk, Alpo. You can feed it to your dog. You could buy this in Walmart or Wegmans. That's where I shop, Wegmans. I don't like Walmart. You can get it at Weiss. My son works at the Weiss in Enwell. You go visit him if you want. Wear a mask. Alpo dog food. What does that remind you of? Here's the metalloids. We got aluminum and we got polonium that touch the line, but they're not metalloids. You know why? They're dog food. It's easy to remember that. Alpo dog food. I make you hold a can in your hand when you come to class. I'll find it or I'll buy a new one. Alpo dog food. Aluminum and polonium are not metalloids. They're dog food. They're actually just metals. Aluminum and polonium are metals, but that's the easy way to do it. So, questions, read the rubric. The rubric says a cover page with an intro sentence. 1 point each, cover and intro sentence. On the first page, put your name and your class period. That makes my life so much easier. Then, all the data for the elements. That's this page. That's upside down. 10 questions. It's not upside down. And then the nickel graph and the water graph. That was on the slideshow. We measured nickels. We measured water. You're going to balance that out on the graph. You're going to draw the best fit line. You're going to do the slope. All right? If you have any questions, you call me up on the phone. If your percent error is more than 10 or 12% in either direction, positive or negative, call me on the phone. All right? Percent error has a sign all the time. Use your units in the math. Don't torture me. You have to show me you know how to do it. It doesn't matter how smart you are. You're all smart. That you're in the class already. That makes you a smart kid. You got to prove it on paper. Do the right thing. Adios.